In this video, we are going to continue to talk about the classification of matter. Then we're going to proceed to talk about properties and the changes that matter can undergo. So first, we're going to explore the classification of matter in terms of physical state. Now, there are 4 different physical states, but in this course, we are just going to look at the 3 main ones that are known. Those are solids, liquids, and gas. In table 3.1 in the textbook, these 3 physical states are compared in terms of their shape, their volume, the arrangement of the particles, the interactions between the particles, and the movement of the particles. And as you can see, the last row gives you examples of each of these 3 different states of matter. Let's first zoom in and look at the descriptions for solids. So when it comes to solids, understand that solids have a definite shape and a definite volume. The particles that are present as a solid, understand that they are fixed and they're very close to one another, so they have strong interactions with each other. And when it comes to movement, they move really slow because, again, they are fixed, they're very close, and they have a strong interaction. Now, in this slide, as you can see, we have an example of a solid because in the bottom, we have an example of quartz. And this specifically is just a precious stone. And at the molecular level, you can see here that this is when silicon and oxygen come together to make the compound silicon dioxide. Okay, so this is just an example of a solid. Let's proceed to talk about liquids. When it comes to liquids, as you can see, liquids actually take the shape of the container. They have a definite volume. The particles themselves move randomly and they're close to one another. They have a strong interaction between each other. And when it comes to actually movement of the particles, they are going to have a moderate movement. And as you can see, in the bottom, we have a glass containing water. So this is a glass with water. Again, at the molecular level, water is 2 hydrogens and an oxygen. The hydrogens are illustrated by those white balls. The red balls in the middle, that's the oxygen. Let's now talk about gases, okay? When it comes to gases, as you can see, gases take the shape and they fill the volume of the container. The arrangement of the particles that are present in gases are random in terms of how they move, and they're really far apart. When it comes to the interaction of the particles, there's actually essentially no interactions between them. And in terms of movement, they move really fast. We are actually going to be exploring gases in chapter 8 of the textbook. We're going to spend a whole chapter talking about them. But here's an introduction. As you can see here, this is just illustrating helium present in some balloons. And helium is one of the gases that are part, and it is an element, and it is part of the periodic table. Now we're going to proceed to talk about properties. So any substance, it can be an element or it can be a compound. Understand that the substances that are all around us will have physical properties. So what are physical properties? They are the characteristics that are observed or measured. But more importantly, it's like these properties that we're going to talk about are not going to change the identity of a substance. They are just utilized to describe the substance that we are studying. But again, they can be observed or they can be obtained by measurement. Some of these include mass, volume, density, if something is a solid, a liquid, or a gas, the melting point of a substance, the boiling point of a substance, the volatility, taste, odor, color. As you can see, the list go on and on. You do not have to memorize these terms, but if you are given descriptions of a substance, you can tell if it's a physical property or a chemical property, which is the next concept that we're going to explore. Chemical properties, on the other hand, describe the ability of a substance to interact with other substances and change into a new substance. So when we're talking about chemical properties, this is going to be, again, the ability of a substance to have interaction with other substances, and at the end, we are going to have the creation of another substance. So as you can see, some chemical properties for substances out there include acidity, basicity, causticity, corrosiveness, reactivity, stability, inertness, explosiveness, so on and so forth. The main thing to remember when it comes to chemical properties is that chemical properties are going to show us how a substance has interaction with other substances, and once that interaction occurs, the identity will change because we're going to be producing a new substance. Okay? Now, also understand that substances undergo changes. These changes can be physical or these changes can be chemical. Now, we are first going to explore physical changes. And as you can see in the definition, a physical change occurs in a substance if there is a change of state, if there's a change in a physical shape of the substance. The main thing that you have to remember, that if a physical change has been taken into consideration, the identity and composition of your substance does not change. Okay? So one of the things that I want to point out are phase changes. And phase changes, understand that they are dependent on temperature. What that means is that if there's changes in temperatures, then some substances can change from the different states: solid to liquid, liquid to gas, or even solid to gas. To give you guys an example of a physical change, here in the illustration, we have a place where salt is created. So if you have purchased in your life table salt or even sea salt, I'm just going to highlight them in the image. These little mountains of a white solid that you see throughout the image that I'm highlighted in green is salt. Okay? Specifically, sea salt. So sea salt, as you can see, seawater is present in these reservoirs, okay? And all is happening is that this substance that is seawater is undergoing a physical change, because when this undergoes a physical change, meaning that we're going to apply, in this case, separation technique, that it is evaporation, what's going to happen is that the water will go from liquid to gas. And then what is going to be left over is that sea salt. Okay, so we're separating through the process of evaporation the water from the salt. Now, in this chapter, you guys are responsible for knowing what are the names of the different transitions that can happen between the physical states that are present in a matter. So, if we go from solid to liquid, that is called melting. If we go from liquid to a gas, that is called evaporation. You may know it as vaporization also. Solids can actually go directly to gas through the process of sublimation. Okay, and these changes are not unidirectional. They're not going towards one direction only. They actually can go in the opposite direction. So if we have a gas going into a liquid, that is called condensation. If we have a liquid, let me do those in different colors so it's a little bit more clear. If we go from liquid to a solid, that is called freezing. And lastly, if we go from a gas all the way to a solid, that is called deposition. Now, let's look at chemical changes. Oh, before I move on, remember, phase changes are always chemical changes. So if you see any of these terms that I just expressed, for the different states of matter and how they change from one to another, that remember that that's always a physical change. Now, let's move on to chemical changes. When it comes to chemical changes, understand that chemical changes, a new substance will form. Another term that is utilized for a chemical change is going to be a chemical reaction. Okay? So that new substance that is created from that chemical change, understand that it has a new composition, new chemical properties, new physical properties. One example specifically of a substance that undergoes a chemical change will be caramelizing sugar. At times, we don't realize that caramelization is a chemicals change. Okay, so here is an example of a dessert that is called a flan. It's a type of custard. The caramelized sugar that is actually utilized during the process of making the flan undergoes a chemical change. Now, in this chemical change, maybe because if you utilize regular language, you will say, oh, but we have sugar, and sugar is converted into caramelized sugar. And isn't that just sugar turning into sugar? Well, these are different at the molecular level. So the molecules that are present in the sugar before caramelization are not the same after a sugar has been caramelized. That's why sugar that undergoes caramelization undergoes a chemical change. Now, there are certain hints that we can obtain in order to know if a chemical change has occurred. As you can see, it can be classified as the change of properties or even the change of energy. So, the first one that we're going to discuss in terms of change of property is going to be the change in color. So, to give you an example, the change in color that happens because of oxidation reaction. And there's many examples about oxidation, is relevant, and it is a chemical change. So for example, the Statue of Liberty has a green color at the present moment because the Statue of Liberty is made out of copper. Copper actually undergoes an oxidation reaction, and that's what gives rise to the green color that the Statue of Liberty is. If that green it is removed by chemical methods, you will see the copper that the Statue of Liberty is made out of. Another example would be like browning apples or browning bananas. That process is a chemical change, and it comes from a change of color. Now, the formation of bubbles is another example that a chemical reaction has occurred. And these bubbles are going to result, okay, from the formation of a chemical in gas form. So as you can see here, in this process, carbon dioxide is a gas, and because it is formed in the chemical reaction, that's why we see the bubbling. The change in odor, so for example, if food is burning, or if you have a food that now has an unpleasant odor, understand that sometimes that represents a chemical change or chemical reaction happening. The formation of a precipitate. In the formation of a precipitate, in other words, that means that a solid formed in the reaction. Now, when it comes to changes in energy, as you can see, if your reaction gets warm or if your reaction gets cold, understand that that thermal energy that happens during the chemical change represents that a chemical reaction or a chemical change has occurred. And lastly, we're going to see the release of energy. When it comes to the release of energy, understand that this can happen at different levels, but the formation of light tells you that there is a chemical change occurring. To give you guys an example, understand that there's certain animals in there that their biomolecules undergo chemical changes, and at the end of the day, we see that these animals, for example, a firefly, will give off light as a result of a chemical change in some of the biomolecules that they have present inside of them. Now, in part B of the worksheet, we have different descriptions and we need to classify them as physical changes or chemical changes. So when it comes to this, I'm going to do problems 1 through 9. Make sure that you look at the answer key for the answers from 10 to 18. So let's get started. Glass breaking is an example of a physical change. Hammering wood together, that is a physical change. Rusting of a bicycle, that is a chemical change. Melting butter is a physical change. Separating sand from gravel is a physical change. Bleaching your hair, that is a chemical change. Frying an egg, that's a chemical change. Squeezing oranges for juice, that is a physical change. And melting ice